Good day. Welcome to our IGCSE Physics series. And we are looking at the first section of topics that you will find in your IGCSE curriculum. Here we will explain some concepts and try to give you a clearer understanding of what is in your textbook. Please feel free to pause and use the resources that we show in the slide series, and also note down anything that you think you will need in future. We hope you enjoy this series. Next segment, significant figures. Now, what is the idea behind a measurement? The idea behind a measurement is for you to establish what the value is or the quantity is that you are trying to measure in an experiment. And the reason that this is so important is the more accurate your measurement during your experiments, the more accurate your scientific data would be. And this makes your experiment results more trustworthy. So the next one, what is the reason that errors could occur? The reason for this is, if we take the ruler again, if you look here, there is a part before the ruler starts to measure, which is also a significant length. We don't know what this length is because the zero only starts a bit after this area which is not being measured. And if you add this part, so if you measure from here to 10 centimeters, then there will be an error because it won't really be 10 centimeters. It will be slightly more than 10 centimeters. So errors occur because people are negligent, or they don't understand their instruments, or they are not familiar with their instruments. So therefore, it's very important to do some research before you start quantifying your experiments in physics. Next one, what is the best way to eliminate error as far as possible? Firstly, it's to do some training on your implements or your tools that you will be using during your experiment. Secondly, if you see that there is a margin of error that could occur, you need to take it into account with your calculations by adding the variable x to your calculations. This shows anyone who is checking your project data or your quantities for your experiment, to let them know that there was a margin of error because of some unforeseen circumstances that you could not avoid. When do we use which amount of significant figures in our experiments? So firstly, what is a significant figure? A significant figure is the amount of decimal spaces that you need to represent in your answer during your experiment. So for example, if you have a calculation, which is, let's say, 4.38 times 2.2, then because there is one value that has two significant figures after the decimal, you have to report how many? You have to report one significant figure because both of your values don't have the same amount of significant figures. So in this case, significant figures will actually help you to eliminate some of your errors as far as possible. Because if you see that your measurement tools, let's go to the ruler again. If you look at the ruler, you can go from 1 to 1 decimal figure because you have your millimeters after the centimeters as well. You can see them and measure them. But you cannot go into two significant figures after the decimal because you cannot measure anything between the millis. You cannot actually measure it in this ruler because it is not available. So therefore, if you are using a ruler, then you will only have one significant figure. So you will say your answer has to be to the first decimal. It has to be rounded up to the first decimal. But if you have a more accurate instrument, then you can use more significant figures after your decimal. So you can add maybe 2, 3, 4, 5, 9, how many ever, due to the accuracy of your instrument. So significant figures rely on your instrument that you are using, and also what your values are in an experiment where you have received the data. So you have to use that knowledge to identify how many significant figures after your decimal you will be using. Let's see, this is question number 5. Which guidelines should we follow concerning significant figures? Firstly, your significant figures should have the same amount of significant figures as the data you have received. So if you have 2 decimal spaces, then your answer should also have 2 decimal spaces. This is a very good way to see which significant figures you are using and which you are not using. Another way that you can see this is basically by saying that anything further away from the decimal is not significant because you are not sure about it. So if you look at these two numbers, you will have 0.86947 is the first one. So 7 is the furthest away from the decimal, therefore we are least sure of this number. And here, in this one, we have 0.357. And again, 7 is the furthest away from the decimal, so therefore we are least sure of that number. Therefore, we would try to round it up at least 1 to eliminate our margin of error. But if we are calculating these two together, either by multiplication, addition, or subtraction, what would happen is both of the numbers would have to move to 2 decimal spaces because this would show us least error. This will be the most sure number that we can be because the further this goes away from the decimal, the least surety we have of the numbers that we are working with. Okay, next one. How can we express numbers in standard notation? How can we express numbers in standard notation? So if we once again take these two examples that I just showed you, we can take them to, we have a 0 before the decimal, so that will be our number 1, right? Then we are moving the decimal from here to between the 3 and the 5. So that means we already had a 0, so a -1 here, and we are adding another -1. So that's why we have to take it to a -2. So therefore, it will be a 3.5 times 2 to the power of -1, based on our previous section that we did on scientific notation. That is all for standard notation then. Thank you for joining us in today's session on IGCSE Physics. We hope that this topic has helped you to gain some insight into what you can expect in this curriculum for physics. Enjoy your day. Bye.